Hi, my name is Bob Hannes. I'm with Western Environmental Technologies, and we're an operations company. We service water and wastewater systems, and we are here today at the Black Canyon City KOA wastewater treatment facility. And we're going to do a short explanation of how it works.
Great.
Yeah, and the engineers will give a life expectancy of about 30 years. And so as you look at jacks, not just to point something out, just to give you knowledge, we got some bad corrosion going on there.
Okay.
It's going to need a new tank shortly. The state just requires so much permitting anymore that it's not a simple solution.
Now, how old exactly is this particular processing?
I'm not sure. It's probably put in the 60s. At that point, somewhere around there. So what we have here is a typical bar screen. The influent sewage or the raw sewage would come in through the bar screen. The bar screen is designed to eliminate any of the rags, any big solids, plastics, and that type of thing that hinder the performance of the pumps. It then just flows into the aeration portion of this system. This is an activated sludge facility. It would flow into here, be treated by the organisms, the microorganisms that are in the system. And the largest amount of time and effort that's taken in operating one of these systems is managing the solids. The microorganisms multiply every 4 hours, and they're constantly consuming the raw sewage, and that's their food that's coming into the system, and they're changing it from a more harmful substance for the environment to a cleaner, safer byproduct.
And you would think that it would be kind of smelly back here, but there really is no smell to this at all. As far as having a bad odor or anything to live around.
Right. They will give off kind of a swampish type odor, like a musty, mildewy type odor, just because the organisms do break down after a while, and you're smelling the organics in the water and in the liquid. So let's go ahead and turn on the blower, and we'll show you it actually working.
Okay. What do the blowers do exactly? What are their functions?
The blowers put air into the system. We have a living culture in the mixed liquor tank. Mixed liquor is mixed with the sewage and the organisms. It is a culture of living organisms that require oxygen. And so we blow oxygen through the blowers, push oxygen through into the aeration zone or the aeration tank to keep the organisms alive. If we don't put air into them, they will consume all the oxygen in the tank and they will die off.
Oh, okay. Oh, okay, yeah. See it churn in there.
So the blowers push air into the system. It helps to mix it, and it helps keep the organisms alive by giving them oxygen. This system here, the oxygen levels vary from about 0.8 to 1.5 milligrams per liter. And that's a good, safe operating range for these organisms.
Very interesting. And then as the water is cleaned over here, it starts running through this area over here?
Yeah, so it starts at the influent bar screen area, comes into the mixed liquor tank or the aeration tank, comes into a clarifier, and it does exactly what the word says. It clarifies. The solids settle to the bottom, the clear water then flows over the overflow weir into a contact chamber, chlorine contact chamber for disinfection.
So that's what this area over here is?
Yes, that would be correct.
The contact chamber.
Chlorine contact chamber.
So that's what he's always putting the chemicals into, is that side.
Yep. Trying to keep it broken down. And this plant discharges to a lagoon system, and then the water just evaporates off.
Oh, okay.
And that lagoon system is right back there past the lilies there.
Oh, all right. Yeah, you can't really see it here.
Yeah, it's starting to get overgrown. The cattails have taken over. So what happens here is, in the clarifier, the solids settle to the bottom, and we pump them back into the mixed liquor tank, because we need to keep the solids in the tank. And we control the amount of solids in the tank by wasting. So we'll have a septic hauler come in 2 times a year approximately as the solids build up, and then we'll have them pump off the solids, basically the mixed liquor, to drop the level of organisms in that tank back to a healthy level again. They'll just keep on multiplying to the point that there's not enough food to support them, and they will die off, and then they will flow out into the lagoon, which isn't good. We want to keep them where they belong in the aeration tank, and so we manage how many organisms are in there by the wasting.
How long do you leave the aeration going for them?
This one runs for an hour on and an hour off. That all depends on the loading. Some plants are set up that they run all day from like 5 in the morning as that first load comes in, showers and what have you, people getting up and going. And then they'll shut off at about 10 o'clock at night, and then they'll come on an hour on, an hour off throughout the course of the night.
Now, is that an automatic thing, or like
Yes.
it does it on its own?
Yes, typically there's timers on the facilities, so through these timers, you can turn the blowers on and off, or turn pumps on and off if you need be. Some of them run 24 hours a day. It just depends on what the loading is and what the capabilities are of the facility.
I gotcha. Now, for something this size, I mean, we are a relatively small park here. So about how many people, like if you had a small village that was using this as their system, about how many people would it support?
This one here handles about 5,000 gallons a day. So it would support, it's roughly about 200 gallons per day per person. That's how much.
Well, that's actually quite a bit.
Yeah.
I mean, we bottle our water because we don't have ours hooked up to the trailer, and we use an average of 6 gallons of water a day at most.
Okay.
But now we don't shower in our trailer and stuff. We use the bathhouse.
Okay.
So, I mean, so that's going to make a difference because you've got all that water that's just going through.
Right, and that's something you got to look at the regulations. I handle a couple of camp areas, and we have some historical data that shows that people really only use 100 gallons a day or 75 gallons a day, but the state will not let us basically redesign the system to allow for that lower flow. They still want the 200 gallons or whatever the statute states, even with some real-time data, because they're concerned about the expansion. What happens once the plant's there? People then start looking up homes to it.
Right.
So they're worried about future use.
Okay. Well, that makes a lot of sense. Anybody who's got something like this doesn't have to go with your state facilities either, correct?
Right. So, and the reason the KOA had to put this in, because there's no city facilities out here. So if they wanted this high density, they needed to put in a wastewater treatment facility. So, typically you have the smaller plants in the outlying areas and not in municipal cities. You can see you got the skimmer water, which is sucking off this foam and putting it back in for retreatment. And then you got a RAS line there, the return activated sludge, call it RAS, being brought back into the aeration tank. And that's the recirculating of the organisms.
That's so fascinating. I mean, you look at it and it's kind of like, ew, but I'm so amazed that there's not a really bad smell. I mean, being in Savannah, we're used to swampy smells.
Yeah.
And we know of some really bad swampy smells. And this is nothing. It's not bad at all.
Yeah, once it gets into the mixed liquor area, the aeration tank, and it gets air, and the organisms start breaking it down, it freshens the sewage up quite a bit, and you don't get a lot of odors off of it. And then again, this is a pretty small system. Where you tend to get the odors is in the early mornings or evenings when the barometric pressure changes and we don't get the lift of the air going up and getting out into the environment.
Now, if you wanted to get some schematics on how to build one of these, where would you get those?
You would have to either contact engineers. You might be able to find some older drawings online if any engineers have posted them. But most of these systems are designed specifically for a camp, and the engineer holds those designs. Kind of a patent type thing. They're proprietary type designs.
Okay.
But some basic Lagoon systems, you could probably pull those out of some old manuals, some old engineering design manuals.
Very interesting.
So there are a couple of things to consider when thinking about putting in a wastewater treatment plant on the regulatory aspect of it. They do require an engineer to design it. To pull permits through the state regulatory agency. Here it's the Arizona Department of Environmental Quality. They will charge for review of the plans and then just construction costs. They're either done, this one's in a steel tank, they're either done with steel or concrete, and construction costs are going up. So that's something to consider when you're doing it. A facility like this, they probably run about $15 per 1,000 gallons. $15 per gallon to put in. So you'd be looking at several $100,000 to put in a facility like this. And then depending on how elaborate the system, how advanced it is with aeration, having to denitrify, and that'll be driven by how you discharge your water. At the KOA here, it's a non-discharging facility. We go to a lagoon and evaporates off. He has the lowest level pipe permit with not a lot of sampling requirements because it evaporates off. If we discharge to a creek or we want to reuse the water for irrigation, that type of thing, the sampling requirements go up quite a bit. And you could go from, where Jack here pulls a monthly sample at, let's say, $40. Sampling can go up to $2,500 a month, depending on what you want to do with the water. It gets expensive quickly. And then the operational side of that, as the system gets more elaborate, more complex, it would require an operator. And as it goes in Arizona, we got 4 different classes, 1, 2, 3, and a 4. And as you go from a 1 to a 4, the cost to operate them and to employ people skyrockets.
Very interesting. So for right now, it may not be the wave of the future, at least not at this moment, because of the cost effective, or the lack of cost effectiveness. However, if you already have something like this set up, then that could be a good way to work around being, when looking at being off the grid, would be a good thing to look into to be self-sustaining. Now, let's go 10 years into our future and say we've had wars and we're at a place where there's been a lot of destruction, there's total chaos in the government or lack thereof, and there's people just trying to rebuild America and survive with some basic modern comforts like plumbing.
Right.
Looking at it on that kind of level, you know, just kind of taking that scenario, let's take it out of today and into a scenario like that. What would you say would be the effectiveness of something like this for rebuilding communities?
Yeah, well, if you think about where wastewater started, we started with lagoons. You know, we had lots of space. The downfall of lagoons is they just take so much space. So as the cities grew and grew and grew, the wastewater treatment plants had to get smaller and smaller. And that's where you get into this technology like the KOA has here. But if 10 years down the road and we have all this chaos, a simple lagoon system will treat the water effectively. Now, it won't treat it to the level that we would want to reuse it for irrigation and that type of stuff, but it would clean it up well enough to protect the environment. It's a step in the right direction, at least.
Okay.
We wouldn't have a high biological chemical demand going out to the creeks and killing all the fish and turtles and all the things that live in the creeks.
Now, do you create the lagoon? Like, if there isn't one, you create the lagoon for it?
Yes.
Is that...
Yep. Yeah, you would dig down. Well, they're designed different ways, you know, probably 8 feet down or so. And then they'd have to be lined with some kind of material. You know, we've gone from, you know, a clay bentonite type thing to actual, you know, 40 mil liners for these, you know, like petroleum type based liner products.
But concrete or anything that would hold the water, like a pool, sort of?
Yeah. Yeah, if you had an old pool or something, you know, typically you don't want to go that deep. But if we had total chaos going on, a pool would be at least a place to start getting it treated. You know, it'd be a place to start, and we'd be getting, at least you'd have, in that situation, it would be like an oversized septic tank, a solid would settle to the bottom, and, you know, your clear liquid would go off, but it would still be getting some treatment because of the air and because of the organisms in the water. You know, the air would just be taken in by the wind. The wind would bring the air into the water, and it could start some beginning of the treatments.
Very interesting. So as long as we have our government in place and regulations in place, this may not be the most cost effective, even though it would put you on your own system and get you away from their own sanitary systems. However, it would be something that could be utilized should we ever need to rebuild our systems.
That is correct, yes. And you'd want to check on the local regulations. You know, you might be able to join 10 houses together and not have as elaborate a system as Jack has here. That wouldn't require the license. You'd still need an operator, a licensed operator, but maybe not to the certification, the level that I carry, or, you know, somebody like I would carry. But a local resident could get maybe a grade 1 license to operate the facility.
So if we really do have a zombie apocalypse, you are going to be the man to call for waste management.
I hope I'm here.